Hello everyone, welcome to my channel. If you have not already subscribed to my channel, please do subscribe to my channel. Today we are going into Proc SQL series which I have started long time back, and today I am going to cover the part 4. And in the part 4 we are going to talk about set operators. Now let us quickly look into what we are going to discuss in set operators. In set operators, I'm going to talk about general properties of set operators, followed by significance of all keyword, followed by core keyword, and also I would like to discuss special case of intersect. All of this we will be discussing through various examples. Now let us quickly look into what do set operators do. Set operators affect number of records vertically. How do they do it? We will look into it very quickly. And what do they do again is they impact number of rows. Basically, whenever we use set operators, we are impacting the number of rows in one way or other. And also, set operators are different than joins, wherein we are usually intended to compare one table to another table completely. And again, this is most of the times. Unlike joins, whenever we compare two data sets or we do something with the join, it is more or less done on the basis of one column or one variable, not on the basis of the whole table. Now, let's get into general properties of set operators. Before going into that, I would like to say the types of operators, how many are they? There are 4 types, and they are union, except, intersect, and outer union. If you see here, I have mentioned in here outer union as SAS specific. In SQL, set operators are there and they are standard for any databases or pretty much anywhere SQL is implemented. Outer union implementation is something which is very SAS specific, and you don't see this kind in any other SQL implementation. Now let's look into union. What does union do? Union appends data and removes duplicates. Now let us try to understand through an example in here. Here we have two data sets, dataset 1 and dataset 2, and in both the case we have two variables, ID and name. And if you see here in this dataset we have 1A, 2B, and in this dataset 1A and 4B. And we can do union of these two datasets as follows, wherein I can write proc SQL semicolon select star from 1 union select star from 2 semicolon quit. So if you see, we are combining these two tables with the help of union. And what this does is it combines these two tables or data sets, and also it removes the duplicates. If you see here, if we just append it in a regular fashion, our result should be 1A, 2B, 1A, 4B. But if we just mention union, it will not allow the duplicates, and you will have only 1A and 2B and 4B from here. Again, to sum it up, union appends data and also it removes duplicates if there are any. Now let us get into intersect. Intersect, again, to explain this topic, I am going to take the same example which I have shown you earlier, where we have two data sets and the data which I have shown you is the same. Instead of union, I am doing an intersect here. When I do intersect, what it does is it gives the common rows, that is 1A, and also it removes duplicates. Intersect is little bit more nuanced, and little bit more details of intersect we will discuss at the end of this presentation. Now let us quickly look into except, and again we are taking the same data set, and if you look into here, the data sets are same, and instead of intersect we are using except here. Everything else is same. Except is little different. What it does is it finds non-common rows from the first table, and if it has duplicates it will remove them. Now let's try to understand this one little bit more in depth. So here we have 1a, 2b, 1a and 4b, and I am doing except, and I am using select star from 1, and this is my first table. Whenever I mention select star for the first time in here, whatever comes second, it is the second table. So here in the first table I have 1a and 2b, and in the second table I have 1a and 4b. If you see here, I am telling very specifically it finds non-common rows from the first table. So this 2b is not there anywhere, but 1a is there. So this 2b is the non-common row. So that comes out as our result in here. Now let us pause for a minute and let's think up for another scenario. For example, if I have mentioned select star from 2 first and 1 later, my result would have been 4b. So the except results depend on the first table. It is not an overall comparison. Even though I am comparing first table to second table, the results which come out are usually from the first table. Now that we have looked into 3 set operators, the 4th set operator, outer union, I will discuss at a later point, and you will understand why I have discussed that at a later point. Now that I have explained these 3 set operators, I want to discuss very briefly the properties of these set operators. But I will explain only through union. But those properties are same for except and intersect. Now let us look into what are those set operator properties. Here everything else is same what I have discussed previously with one change. That is, in the first data set I have the variable name changed to new underscore id from id. So when we do union, what it will do is the result will be exactly same from what we have seen earlier. The only thing changes here is the variable name changes to new underscore id. And I want to discuss at least couple of points here so that the concepts are a little bit more clearer. So if we have done the same kind of thing somewhere in our data step, you have to remember that in data step, whatever we do is lot of variable dependent. That is variable name dependent. But here it is always about position. Here new id and id, they match. Means their data types are same. So here the append happens and they come out in the same variable, but the name from first data set. This is an important observation from the regular SAS properties what we do in data step. Now let us look into another property. That is, here we have the same data sets and everything is same. Only thing we have changed is data type for id. And here we have a character, and in the case of here we have a numeric variable. So we cannot do a union, intersect or except whenever we have different data types, and we are going to get an error saying that this particular id and this particular id are not of same data type. So in SQL, in general, all it matters is position, not the name of variable. Now let us look into something different than what we have been seeing, that is all keyword. Now I will explain this all keyword with the context of again union, and then I will not be explaining the same thing for except and intersect because it will become very redundant. The results will be exactly what you expect. But let's try to understand the all keyword. Here we have two data sets which we have seen, and when we do union, whatever is the common observation here, that is 1A, it is removed. Here the append happens and also a duplicate is removed. But when we add an all keyword, it does not remove duplicates. It just straightforwardly appends. Now let us see what is the advantage of this kind of scenario. Whenever we use all, what it does is it just easily appends both of these data sets. But when we do not have this all keyword, what happens really is, first, the SQL optimizer, what it will do is it will first check whether there are any duplicates. If there are duplicates, it will remove the duplicates and then it will append these two data sets. So if you see, whenever we just use the keyword union, it has to take two passes. The first pass is to check whether there are any duplicates within the data set or with other data set, and then if there are, it will remove. That is the first pass, and then it will append. With the all, it just appends without doing those two passes. For example, you have a data set which does not have any duplicates. You can simply use union all, and it is much more efficient as it has to go only one pass. And also, if you are fine with the duplicates, then you need not use just regular union, but you can use union all. So union all will be little bit more efficient. And now, as I said earlier, it is the same with the case of intersect and also accept. Now let's look into something entirely different, that is outer union. Outer union, as I have explained you before, it is super different than what we have seen, and it is SAS implementation. You don't find this kind of thing in another databases or another SQL implementation. Here, let's try to understand outer union. Here again, I have the same two data sets. Instead of union, I am using outer union. What this does is it just stacks, it just appends. But if you see, it does not understand anything. All it does is it sets up the values for first data set and then sets up the values for second data set as shown in here. And there is no all concept here. If you see in here, ID are same, name and name are same, we know that. But they are stacked differently as a different variable. Now, if we want to come together as we expect that ID values of these two and these two match, then what we need to do is we need to use a core keyword. Now let us try to understand this through an example again. Here, everything being same with what I have shown you before, all I have done is added a core for this outer union. What this core does is it combines the data sets on the basis of column name or variable name. Now let's quickly go back and see our simple outer union. Here you can see that simple outer union just stacks. But what it does not do is it does not combine the variable names. This kind of results are pretty useless. So outer union without core does not make much sense. So whenever you use outer union core. And also there is no concept of all in the case of outer union. So whenever we do outer union, always remember to use core, and here we will not be able to remove duplicates. Now let's go a little bit deeper into the concept of core, but this time we will be trying to understand with relation to union, accept and intersect. I will be showing only the results with relation to union, and I will not be discussing about accept and intersect, as this will be very redundant if I do so. Now here we have data sets, and in these data sets we have two variables, ID and name, in the first data set. In the second data set, if you see, the variable names are ID and names. Now if you look closely, these two variables are not same. And if we do union core, what it is going to do is, it is going to only combine those variable names which are matched. Now if you see here, we have a result in which we have only ID variable, because only ID and ID variable names match. Now let us look into union. Everything is same here, and all I have done is union. When we do a simple union, if the data types match, it's all good, and then it is going to combine the data sets, and the variable names are picked from the first data set, as I have explained earlier. Now here you can see that union core is depending on a variable name, whereas in the case of union it is all about data types in the positions. If they match, the append or union will happen. Now let us dig even deeper and try to understand in what kind of scenarios union core might be useful to us. Let's look into the example in here. Again, I have two data sets here. In these data sets, the variables are at different positions. What do I mean by that? Let's quickly look into these two data sets. I have variable name and ID. Name is in first position, ID is in the second position. In the second data set, ID is in the first position, but name is in the second position. If you see, there is a variable names match, but if you see, the positions do not match, and if we are going to do a simple select star from one union, select star from two, it is going to fail, and it is going to say that the data types are not matching. Here again the same data sets and the variable names are at a different places, but the names do match. So what happens is, it picks up the variable names from the first data set and it gives the results as shown in here. This is very useful whenever you have different data sets where the variable names are not at the same position, but variable names are same. Now let's also look into outer union core and union core to understand it even more better. Now we have data set 1 and data set 2. Here in data set I have ID and name, whereas in the case of dataset 2 I have ID and new underscore name. What outer union does here is, it will combine both the data sets, and as I am using core in outer union here, whenever the variable names match, they come into same variable. Whenever the variables do not match, that is in the case of name and new underscore name, they do not have counterparts in both the data sets, so they just stack as shown in here. Now you can see that this outer union core is giving results Whenever the variable name matches, it stacks, and when they do not match, it still keeps those values in here and those variables in here, but missing values whenever they don't have counterpart. But when we use the same data sets and we do union car, it is only going to give one variable, that is ID, because that is only the match. This is the main difference between outer union car and union car. Now, if you look closely into the results of outer union car, what we can see is this looks very similar to our data step results. We can append the data set in data step by using a set statement and mentioning data set names, and you get pretty much the same result. One use of this outer union car or all the set operators is, more than often whenever we are using set statement or doing any kind of merge in data step, we should be always be careful of length statements, and we can land up in data truncation. And we can avoid this by using this outer union car or generally SQL whenever we have different length in different data sets. I have made a video on the same topic and I will give the same link in the description below. And now let's look into other topic, that is special case of intersect. Now, as I said to you earlier, intersect is little different. Now, what I want to show you in here. Now, I'm doing an intersect all here, which means it should not remove any duplicates. Now, let's look into our data set. We have data 1 and we have data 2. And here in data 1, I have ID and name, and data 2 also have ID and name. But if you look into observations, I have 1A, 1A, 2B, and here I have 1A and 4B. Now after intersect all, we are going to get the result as 1A. Why are we not getting 1A, 1A and 1A? Why are we just getting simple 1A? Even though we have intersect all. Now we can understand this better by looking into another example, and we will quickly come back and I will address this in a minute. If we see the data sets here, I have 1A, 1A and 2B in dataset 1. In dataset 2, I have 1A, 1A and 4B. If you see the result in here, I have 1A, 1A. Now what can I interpret here? Now to understand intersect, what we also need to understand is whenever I have 1A here and 1A counterpart here, that means it has a match. So that's what we see in the result in here. And 1A, and there is 1A for this 1A. So that's what we see in here. So to understand intersect, what we have to understand is the exact number of values should also match in both the data sets. And now let's quickly get back to our earlier results. If you see, I have only 1A because for this 1A in dataset 1, I have 1A here. So that is what we see in the result in here, but there is none for this 1A. That's why we do not have anything in here. So this is an important point we need to understand in intersect. Now that we have discussed a lot about set operators, I quickly want to summarize this. To summarize this, what I have done is I have made all the information in groups. So in the first group, I am saying as a group 1, I am going to summarize about union, accept and intersect. Simple union, accept and intersect, they operate by position. They take name from first table. and data types should be same. Those are the requirements for union, except and intersect. Whereas when we use all keyword along with them, that is in my group 2, they will not remove duplicates. When you do not have any problem with the duplicates, then you should always use all keyword because it's more efficient. Core operates with variable names. Now let's look into group 4. Group 4 is about outer union. In outer union, everything gets stacked and we always need to use core keyword to match column names. If we are not going to use core, whole the outer union concept becomes pointless. Unmatched columns will be there in outer union core, which is different from regular union core where unmatched columns will not be there in final output. There is no concept of all for outer union. I have not shown you couple of things. That is, I can also use union all core. The results will be like what you can expect. That is, it is dependent on variable names and also it will not remove duplicates. And also I have shown you set operators with only 2 data sets. But more than 2 data sets can be used in set operators. I have shown only 2 data sets to keep the whole topic little bit simpler so that it is easy to understand. And also one another important point to note here is except results are dependent on first table of set operator. That's all for this topic. If you have liked this topic, please give it a thumbs up, share and subscribe. Thank you.